Hello all, I'm Dominique Nguyen, and today I'm here for my final discussion. During my second speech, I discussed several different methods such as biometrics, hardware token push notification, SMS text, voice-based, and soft token TOTP. I also talked about two-factor authentication. As you all know by now, 2FA is a security protocol that protects users by asking them to verify their identity using two authentication methods. This first factor is a legacy method, and for today's topic, I will present the second factor, which is time-based OTP. I will go over the implementation of time-based one-time passwords, TOTP, also referred to as soft tokens, 2FA, with Python and the PyOTP module. PyOTP is a Python library for generating and verifying one-time passwords. It can be used to implement two-factor or multi-factor authentication methods in web applications and in other systems that require users to log in. The TOTP algorithm is defined by the RFC 6238 standard. It relies on two pieces of information: a shared secret key between server, such as a bank or school account, and the client, which is the user's mobile device and time. It generates time-based, short-lived passcodes, normally lasting for some specific limited time. Hence, there's a little to zero chance that an intruder can successfully guess and validate the passcode. It works by asking the user for a token, usually sent in an SMS, email, or from a generated secret key to the user's device with an expiration time. It compares the provided token with the actual generated token, then authenticates them if the corresponding tokens match. The TOTP authentication consists of two processes: client registration and client verification. In the client registration process, client registers users' credentials with the server. The server then generates and shares a 32-character secret key with the client as the second factor for logging in the client's account. Both the server and client will store that secret key away for future authentication. In the client verification process, client initiates the login by entering the client's username and password. The server verifies the client's credentials and then inquires the client for a 6-digit TOTP code. The client sends the code to the server by using the previously shared key stored in their authenticator app and on their mobile device. Upon receipt of the client's code, the server generates its own code using the same shared secret key and compares it with the client's. If the code matches, the server grants access. If the code does not match, the server denies it. Now we'll talk about the tools used to create this 2FA demo. The first tool I will use to implement 2FA is the app Spider, which is an IDE supporting Python program. Spider is an open source, cross-platform integrated development environment for scientific programming in the Python language. It is a scientific environment written in Python and only for Python. It integrates with a number of scientific Python packages such as PyOTP, Twilio, tkinter, NumPy, SciPy, Matplotlib, as well as other open source software. The program I will write today to implement TOTP2FA will utilize these three libraries. First is the PyOTP. It is a Python module for generating and verifying one-time passcodes. Second is Twilio. It is a software that allows software developers to programmatically make and receive phone calls, send and receive text messages, and perform other communication functions using its web service APIs. Third is tkinter. It is a graphical user interface GUI module for Python. You can make desktop apps, windows, buttons, show text, and images, amongst other things, using Python. First of all, to implement 2FA in Spider, we need to import the following Python modules into the program: PyOTP, Twilio, and tkinter. Next, we will create a TOTP class named TOTP and initialization codes, such as the secret key and timer parameters. Next, we build the secret key generator function. This function is used by the server to generate a random 32-character secret key that will be shared between server and client. Next, we build the OTP generator function. Basically, this function generates a TOTP code using the shared secret key. I've set an interval for the code to last up to 40 seconds before it generates a new code. This next function is to verify the OTP by comparing the code received from the client and the code generated by the server. If it matches, the code is verified as valid. Otherwise, the client code is deemed as invalid. Next, I use the tkinter functions to create the timer that we use to test the expiration of the TOTP code. And finally, the last function is to create a TK window which will be used to test the following program. And now for the live demo. So first off, we start by running the actual program. As you can see, they have sent me a 6-digit OTP code. A TK window is generated the first time this program is ran. In this window, on the very top, is the secret key generated by the program. This secret key is shared between the server and the client. I've displayed it in this window for the purpose of demonstration only. Below the secret key code is the entry area where we can enter the code for verification. Under the entry area is the verify button that is used to verify the entered code. Below the verify button is the new TOTP button, which is used to generate a new TOTP code. The last thing is a timer that I'll use to show you the expiration of the code. In this case, it is set to 40 seconds. Now, I will show how the actual program works. I will create a new OTP. As you can hear on my phone once again, I received a text message with the 6-digit TOTP, which I will show to you now. The code generated is 299750. So I'll enter in this code. 29975. Let's see if I enter in an invalid code. It should prompt me that this code is invalid. As you can see here, the code is prompted as invalid. Now, if I type in the correct code, it should prompt me that this code is valid, which it has here. Next, I will show you the code should last for only 40 seconds. If I click on this new TOTP code, it will generate a new code. Before the 20 seconds passes, or the 40-second passes, it should be the same code used here. This code here, as you can see, is the same code that's sent to my phone, and it is the same code, 611408. Now let's wait for 40 seconds, or until 40 seconds have passed, to see if they will create a new TOTP code. Alright, 40 seconds have passed, the new TOTP code I generated, 251207. And that concludes my demo. I've shown only briefly how to implement 2FA by using Python. Just remember, 2FA is by no means the most secure method, but it is a start in the right direction. This concludes my presentation. Thank you all for listening and have a good day.